Good afternoon, ladies and gentlemen. I am Aniket from EDS Technologies and I will be your host for today's webinar. First of all, we thanks each and everyone for taking out the time and joining the webinar, how CAVA can help analyze exterior and interior parts of automotive products and fulfill legal requirements. Now, I would like to introduce Mr. Chandrakant Akhade. Chandrakant is an experienced professional with around 18 years of experience in areas of IT, CAD and PLM technologies. He has demonstrated success for managing various CAD PLM projects and services in various industry vertical by means of positive attitude to manage customer issues and escalations. So I would request Mr. Chandrakant to please give the corporate profile of EDS Technologies. Over to you, Mr. Chandrakant.
Thanks, Aniket. Hope I am audible. Yeah. Good
Yes.
afternoon, all. Yeah, thank you. Good afternoon, all. On behalf of EDS Technologies, I welcome you all for today's webinar on analyze exterior interior parts of automotive products and fulfill legal requirements. I thank you for logging here today and taking some time out of your busy schedule to attend this event. My name is Chandrakant Akhade. I manage pan-India technical support function for the solution which we sell to our customer. I am based out of Pune office. We have a very interesting session with the presence of our industry expert from EDS Technologies. Before we go ahead, as you can see on the screen, I'll be talking about EDS Technologies. As you are aware, we are largest PLM solution provider for almost 30 years now, doing entire business transformation along with our customers. So EDS journey started in 1994 with business partnership of Deneb Digital Manufacturing Solutions. It was our own company, started in 1985, and our investors were based out of USA. Dassault System acquired Deneb in 1997, and that's how Deneb software was rechristened as Delmia with Dassault Systems portfolio. In 1998, we became first partner of Dassault in India with the flagship product of CATIA V5. Before that, V4 and mainframes V3 were also there. Since there is no looking back for us also. Today, it's pretty long relationship of almost 30 years with Dassault System also. We are the largest and platinum partner of Dassault in India and also ranked among top 5 of Dassault partners worldwide. So you can see on the screen our basic operations, modus of operandi. You can see we focus on the innovation. We interact on a lot of new technology adoptions. We interact on customer with a flawless of execution. We see how our customers can help accelerate time to market. And we have many cross-vertical solutions. We have, as you can see on the screen, we have almost 11 locations across pan-India. We prefer as far as possible to be near to our customer base. We have overall 2,000 plus active customers and 200 plus team members pan-India. Through all these 11 locations, we are supporting our customers. So with our solutions, we support almost 12 different industry verticals, primarily automotive, aerospace, industrial equipment. And these are our core business solution, starting from virtual twin to business consulting to geospatial intelligence to 3D printing to electronic design automation. To a lot of times, we interact with our customers on military simulations and training, and of course on the mining aspects. Sorry. So with virtual twin solutions, as you are aware, our biggest flagship product from Dassault System, which is now it's very much upbeat in the market, named 3D Experience Platform. So primarily, what all functions that any customer do in terms of designing to concept to design to proto to machining to manufacturing to assembly and to dispatch or delivery. All these functions under one umbrella is taken care by under one platform named as 3D Experience Platform. So for CAD aspects, Similar like CATIA, we have CATIA 3D experience platform, and on similar lines, simulation, collaboration for manufacturing, we have respectively Simulia, Innovia, and Delmia. Apart from Dassault System, which is our strategic partner, another important partner for which the discussion of topic today is about Technia, for which CAVA and QChecker are our flagship product, which out of which CAVA specific features we'll be discussing as a part of agenda of today's webinar. Apart from that, through Humanetics, we also support Ramsys, which is a dedicated ergonomic solution. Uh, Coming to business consulting, uh, we support customer in terms of entire uh, setting up a process from design to management, change management to ERP integration. So entire project management, quality management aspects which are followed at customer end. We help and consult customer to deploy these processes digitally through 3D Experience platform. Then we also support through our optical solutions wing. We also support through Synopsys a lot of optical solutions in terms of lighting, its refraction. It's all lighting study through our optical solutions we do along with Synopsys tool under our optical solutions vertical. So there is one more important vertical named geospatial intelligence. So all types of uh, geospatial intelligence through mapping of GIS application, analyzing all the GIS data that we get. So that is done with our strategic partner ESRI, and we support many defense or government institutes for doing, or academic institutes for doing this type of analytical study. In addition to this, 3D printing is one of our core area now onwards. We have EOS 3D printers, as you can see on the screen, which are primarily for metal as well as for polymer printing. So this is DMLS and SLS technologies, which are selective laser sintering technology, is being used into EOS for printing any component or any job that per se. Apart from that, Automotive is very our recent association now, which are electronic components of 3D printing through aerosol jet technology AJT. We perform through our Automotive strategic partner. In addition to that, electronic design automation is one of the really important field now. We can see with the growth of EV in the market. So a lot of times there are more electronic components than traditional mechanical components. So with Synopsys solution, we do this electronic design automation, which is one of the very upcoming and growing field amongst all our tier 1 suppliers. Next, coming to military simulation. So a lot of wargaming solutions, terrain building solution. So war readiness is there, for which we are partners of MAC Technologies primarily, and it's for all simulations, military simulations. We are interacting with our defense customers in military simulation and training wing. We also have a mining solution. So typical all mining application where all mining is done. So it's all layout, how mine planning, execution has to be done, evacuation has to be done. That is all done with our Dassault system solution named as Geovia. Lastly, learning solutions. So it's our own IP based on our all 200 associates, technical associates with their cross-functional experience and domain understanding. We have also created a lot of domain courses. So automotive perspective, you understand there are a lot of domains are there. So people need, apart from tool training, they also need a lot of times this domain training. So based on our experience, we have also devised multiple domain courses. You can also look at our website for e-learning solutions that we are doing as our own IP. So that is all about in brief as a business portfolio end to end, what we handle to support our customers. So going forward, I will just introduce my colleague. I'll just introduce my colleague, Mr. Sushil Punaskar. He is senior solution consultant in EDS Technologies. Sushil works as I mentioned, senior solution consultant at EDS for specialized application such as Ramsys, QChecker, and CAVA solution. He has around 20 years of industry experience. He has worked with many of the major Indian and European OEMs. In addition to ergonomics, he also is specialized into BIW uh, uh, domain per se, composites and carbon fiber BIW design. So Sushil will take us through the agenda of down the line how Kava as a subject perspective analyzing exterior interior components of automotive products, how the legal fulfillments are there. So yes, over to you, Sushil.
Yeah, thank you, Chandrakant sir. This is really interesting session going to be. So to introduce myself, I'm Sushil Punaskar from Medias Technologies. So next 1 hour we will see the CAVA application as such, what it has to offer to the product development system in automotive scenario. So this is a brief agenda we will see together that we'll talk about the compliance overview, that what are the global compliances that are regulatory in nature, and we'll see what are the drawbacks of manual compliance checking, uh, what are the loopholes and lacunas in that manual checking methods. We'll see what are the if we deploy CAVA to mitigate that risk of manual intervention, what are the benefits of that. We'll see shortly about the overall CAVA overview. CAVA as a whole is a big package of capabilities. Then we'll see module by module and capability wise details. Then we will introduce you to the topic of today, that the CAVA safety module, typically talking about the interior and exterior safety from pedestrian point of view and from interior occupant point of view. We'll talk more about how to check regulatory compliances in CAVA safety radius for the both interior and exterior, and it will be followed by kind of a walkthrough and demonstration of the CAVA safety radius right in this webinar today, and it will be followed by a question and answer session at the end of the session here. Yeah, so it's going to be an interesting session for sure. So let's spend together around 30 or maybe a 1 hour time. So we'll see here, this is complete overview of the continent-wise regulations that are applicable for the cars being made and that cars and trucks being made in that continent. So we have for North America mostly FMVSS standards and SAE standards. For Europe region, we have EC and EWG standards applicable, and these are regulatory in nature, so we have to follow them. Then in India, we very well know that we have the automotive industry standard regulatory in India. Then Japanese standard, MLIT standards, and also the Australian design regulation standard, which is called ADR standard. So we have just enumerated what all regulations are available in CAVA. For example, this rear view mirrors, mostly predominant FMVSS 111 is there. Then for the seat belt anchorage zones and certification of that into the digital environment, we have this ECR 14 and bumper, and we can do also a lot of mannequin checks, ellipses creation, and etc. We can also populate the SAE 90 SAE template right into the vehicle space and check leg rooms and headrooms, etc. And of course, the head impact, what is the topic of today, the safety aspect, we'll see. So and recently, glad to tell that we have recently introduced wipers regulations in CAVA for both M1 and other than M1, that is AS19 and AS11, by which you can certify your wiper system right into the CAVA and face the certification test very confidently without any failures. Okay, let's move ahead. So we'll spend a couple of minutes here that when we check the compliance, what are the drawbacks when we check just by the manual method? I mean, we purely depend ourselves on the manual methods of checking. So there are a lot of loopholes in that, or some disadvantages, because today's product development system is really fast in nature. There is no scope of any repeating the things and errors, etc., because errors can cost a really lot to the OEMs and ESPs. We have to be first time right to be have to be really honest here. So the first thing is that complaints are very critical in nature. They are legal requirements. They have to be met. And if they are not met, then we can't really put the vehicle on roads. That's how critical they are. And they have to be checked really carefully because errors in this can really cost a lot. It's extremely costly affair if we have to look at from error point of view. Then manual checks, as you know, may not be 100% reliable because there is always a chance of manual human error, which can't be ignored in any scenario. Then we also there's a skill dependency. We have to have some specialized people always, all the time, in-house to perform these regulatory checks, which become their quite a special skill. Uh, so in CAVA, you can get rid of this thing. This is completely neutral. Anyone can perform the checks, and the output is really the same. Secondly, to perform manual checks, it's too time consuming. If we have to just read the standard page by page, take the notes, do this whole process into the CATIA, and do it manually, it's actually a very time consuming, and it's really monotonous job. It's really time consuming. So this again one of the drawback of manual checking. After the checks are performed, there is no statistics data available, like what are the areas that have failed the regulation, what is the area that are passed. So that statistics is not available. We have to make a lot of presentations, take a lot of snaps, put in the presentation, do some really markups, etc. So that time is really wasted in that activities. In case of amendment of the any regulations, we have to again do it all over again the same amount of time or maybe slightly less can be again have to be reinvested here, which is not required at absolutely. Then due to these delays, we can't really give a very quick feedback to the styling team or the studio team, which they need actually quite fast responses from the R&D team. So with the help of this, due to this manual intervention, we can't really provide the quick feedbacks, and the very effective development time is lost in that. Also, due to this delay, we can't freeze our styles very well in advance because this checking becomes a bottleneck activity in the whole process. Unless this style is checked from all the aspect, we can't give the go ahead for styling freezing. So this also because it imposes as a bottleneck activity, so which can also eventually lead to the delayed deliveries and then delayed style freezes and a lot of other subsequent gateways are delayed. So this is what a brief about the manual checking uh, drawbacks, I would say. But we have CAVA now in place where it can solve not just these problems but many other problems. So we'll see some couple of like not couple of but many advantages what CAVA can offer to R&D professionals to make their life easy in a way. So CAVA is a fully automatic regulatory compliance check. There is a very minimal amount of manual intervention needed. It's all completely digital. You need not depend on any skill of the engineer. Anyone can perform this if some basic training is given, and the results are same. So it's a neutral. I mean, anyone who performs, the results are going to be same. So there's a neutral. You need not depend upon the engineer skill, etc. CAVA, since it's built on the CATIA CAA language, it's extremely fast calculation. It's ridiculously fast calculations. So it's as fast as CATIA, you can say like that. Then there's a 100% correlation between the digital and physical correlations. If you do it in the manual method in CATIA manually and you do in CAVA, there's a 100% correlation of the output results. So you can be 100% sure that CAVA will give you the 100% accurate results for compliance checks, which is required, which is a need of the whole activity. Then all global regulations are by default available. You can look at American regulations, European, Japanese, etc. They are all available in CAVA. And not that, but even amendments are taken into account year by year and quarter by quarter. It's available on the user-friendly CATIA V5 native platform. So the user interface is quite known. We are friendly with that CATIA V5 interface. So the user interface is not very scary. We are aware of that. So that's the benefit. You need not have any data transfers. You can have a seamless interaction between the compliance checks and the design job. Just the design workbench has to be changed from geometrical shape design to CAVA workbench. So it's a very seamless transfers. You can perform maybe days and weeks job. For example, this safety radius checks are, it takes a lot of time because it's quite a deep and quite a complex algorithm and quite a complex job. So these type of jobs you can really do in hours technically. You can really provide a faster feedback to the customer, maybe overnight feedback if you're working for an offshore client. You can, the moment you get maybe in the afternoon some styles, updated styles, you can provide the feedback to the next day to the OEMs. So that fastness you can expect from CAVA only. Then if any styles are changing, then analyzing the change inputs is really fast in CAVA. Again, the same speed is there. Then with the help of CAVA, you can really provide very fast feedbacks to the studio team, which will be very happy about receiving the fast feedbacks. So if the non-compliance areas are found, if yeah, and overall you can really faster your overall development, which is required, which will if it is a ESP, it is really time is the money. So you can, if the moment you do your activities faster, you can charge the customer equally higher and etc. So and meet the requirements. So these are all benefits why we should look upon CAVA as to make our life very easy and take that risk of manual interventions and slowness, etc. That all will be taken care by CAVA itself. Yeah. So CAVA. So what is CAVA, by the way? CAVA is an abbreviation, of course. It's not a word. It's an abbreviation that stands for CATIA V5 Automotive Extensions for Vehicle Architecture. And it has a total 5 modules. Firstly, the overall vehicle architecture, where many number of architectural inputs. For example, the approach angle, departure angle, the water wading depth, the curved stone clearances, the dynamic curves and static curves. All those are actually can be produced in CAVA with extremely fast calculations. Then we have CAVA Vision as one of the module. Yeah. And wherein we talk about indirect vision and direct vision, and appeal obscuration also can be calculated in just minutes actually, which otherwise takes a lot of time. Then we have CAVA safety that we are talking about now, where we'll cover pedestrian safety, then the interior safety, exterior safety, etc. And we have CAVA mannequin here, where we'll talk about a lot of generation of ellipses, head forms, and populating the template, the SEJ template inside the vehicle space. So everything can be done. And of course, the CAVA wiper for passengers and commercial vehicles. So today's point of topic is actually the CAVA safety here, which we'll talk in more depth here. So CAVA you can use or you can implement CAVA from very early stages of development, right from where you have just the SGRP and some architectural layouts. So for example, the first row population and the second row population, and the vehicle overall wheelbase and FOH and ROH and wheel track details. It can start from that activity and then it can run up to your complete homologation phase. So you have the power of CAVA or you have the support of CAVA throughout the development phase. And you can make use of CAVA to justify your designs and justify your design selections also many times. As I said, CAVA has a total 5 subsets. It's a big package of modules, around 70 to 80 modules are there, or capabilities. They are bunched in these 5 subcategories, what we call OVA, vision, mannequin, safety, and wiper. And we'll see safety today in more detail. So to perform any CAVA study, we will have to first create the base data, which is a set of some very simple inputs, hard points of the vehicle, which we declare in CAVA, and then subsequently after declaring, we can go for next studies for OVA or vision or mannequin or whichever we want. So creation of base data is very important. That is the first and foremost primary step in CAVA. Again, when CAVA workbench will be installed, you will have it can be integrated with your CATIA also. It can have a different environment also, and then it can be found. CAVA can be found in infrastructure, CAVA vehicle architecture. You can find the workbench here directly. Once clicked, it will launch into this user-friendly CATIA V5 environment with different toolbars, of course, pertaining to CAVA. So it's a OVA toolbars, mannequin, vision toolbars. So depending upon your licensing, you will have these toolbars available to you. Let's talk about the CAVA base data. So we have to provide in the initial phases very small, very clear inputs to the CAVA, like overall data, what is the wheelbase, what is the wheel track, what is the FOH, ROH, FOH front overhang and rear overhangs, what is the SGRP location. Also the wheel locations will be required, not absolutely mandatory, but if you give it, it will add a lot of realisticness to your analysis. And in seat, you need SGRP locations, you need ball of foot, AHPs. Also the seat track length, you need the fore and aft adjustment of the seat, that value, and also the seat back angle you require. With the help of these various preliminary inputs, which you will of course get from your OEM as a in a package, you can start your subsequent analysis in CAVA. For example, the first in the safety module is the CAVA pedestrian safety. We are now started with the safety details module by module. The first and foremost is the pedestrian protection, which is again safeguarding the pedestrians in the case the vehicle collides or banks the pedestrian. So how to safeguard them from the structure of the vehicle. So we have to keep some soft zone on the hood here. So for that, we have to analyze which are the areas that the occupant may fall or the pedestrian may fall his head on. So there are some grid markings are to be required, which are the technical checkpoints. And then we ascertain a lot of values below the hood to check the hard points and etc. So CAVA can create a lot of areas directly on the hood. For example, the WAD lines, wrap around distance lines can be calculated on the hood, and also on the farthest line is falls on the windshield here, which is I think WAD 2100 line here, which falls on the windshield. Then you get the grid marking, so you can then certify having these WAD lines and markings. You can really engineer your hood and the underbody structure or the hard points in such a way that if the pedestrian eventually or unfortunately has some accident with the car, then the structure will not create him or her the major injuries or head injuries or knee injuries. So that's how we are making the vehicle safe toward the pedestrian. So CAVA can do all these checks as mentioned here with the help of these inbuilt regulations for Euro NCAP and GTR and EU regulations. You can comply to those legislative regulations also, yeah, with the help of CAVA. Secondly, again, the pedestrian offset. Again, I will play a video here. CAVA is far more advanced than we think. So we'll just play. There is a pedestrian offset. For example, if I show you here, this total line, the 2100 line falls on the windshield, but there's something called active hood, which pop up the hood in some vertical fashion by some amount, so that there is extra cushioning or extra soft zone that is available for the pedestrian hood to fall. So it called active hood. There are two mechanisms. One is pyro activated, and one is there is a separate airbag for that windshield. So there are two mechanisms for that activating active hood mechanism. You will see one video why. Pedestrians don't always stop and look and listen, so pedestrian injury mitigation pop-up hood makes an accident, well, safer for everyone. In a frontal collision, it helps the pedestrian roll onto the hood instead of smashing into the windshield to reduce the injuries they sustain. So I hope you saw this. There's an active hood here. It is the mechanism is mounted onto the hood hinges. So it pops the hood and it provides the active cushioning here so that the head doesn't collide any hard surfaces. So this also active hood can be simulated or it can be complied in directly in CAVA. There's a possibility of that. And this image, if you see on the right top corner, is actually some kind of a heat map of the underbody structure. Some are plastic, some are elastomeric, and some are metallic structure here. So these graph or this heat map gives a good idea that how far our hood top surface is from the hard surface on the underbody. So there is certain, every company follows some certain guidelines for that. Some companies starts with 100 millimeters as a soft cushioning zone. So it depends, and you can set the value. Then you can know what the green areas are more than 100, red areas are actually less than 100. So there's a good heat map to ascertain our underbody areas from a safety point of view. Again, as I said, active hood can be simulated. It's a CAD geometry and it's a physical vehicle setup here, how the active hoods are initialized. And then what we get, what is of great importance is something we call the pedestrian offset. It is an highly important architectural surface available with integration people who produce this surface, and it is a input to many engineers like hood engineers and underbody engineers and also trim engineers. So it's a technical importance of this surface is that uh, everything below this is then hard. It's supposed to be hard geometries, and everything above that is supposed to be kind of energy absorption geometries, which is called soft geometries. So this important surface can be calculated in CAVA just with a click of a button, which otherwise is an extremely ridiculously time-consuming affair to calculate the offset, pedestrian offset. So it's a very wavy surface, taking care of a lot of geometries, etc. So this can be just in minutes. It can be calculated very quickly in CAVA, which by which then the underbody engineers and the other engineers can start their actual design activities. And there are many incidences that this surface can become a point of dispute in the latter stages of development. So it's always good to have these surfaces right from the day one of the development available to all engineers. Again, we'll see how CAVA can be used to engineer your bumper, front and rear bumper from the knee impact of the pedestrian. So if I play a video here, there are two vehicles that will perform the same action. It is a slow speed impact test, which is again in Europe it's called insurance compliance test. So we say if I play here, so you see this is not certainly a good design. There is a lot of deformation, a lot of metal structure is coming and banging the knees, which is representing a knee form here. Again, then we see a second, a more nicely and intelligently engineered vehicle here, at the same speed. So the test criteria is same speed, vehicle category same, the knee forms are same, but the level of injuries, if you see, it's quietly absorbed nicely. There is no deformation on the vehicle also, and due to this bumper, which is actually a soft nose bumper. So we have a soft nose bumper here that can absorb a lot of deformations. So we have something called soft nose bumper here, where the bumper wraps around the up to the hood level. So this is very intelligent design to mitigate this knee injuries, and it is again good for the vehicle also because no apparent damage has made to the vehicle, which is safe from the insurance claims and etc. So CAVA can certainly benefit in these regards to engineer your bumper, fascias and etc. So let's talk ahead about the CAVA exterior projections. Now we are talking about the front and rear bumpers and trunk leads, how to check and comply to the legal requirements of gaps and radius requirements. There are three methods. First, for the lamps, the lenses, and how to measure the gaps and etc. So the projection here is the two touch points, the green and the red, and this is the projection measured. That is the technical value of the projections. Then we have some fins here in the grill area. So how to measure the gaps in that. There's a 100 or a 50 radius spear for the exterior, and for the interior it is 82.5 millimeter spear that represents the head form, and this technically represents the knee form. So these are the different methods employed for radius checking. And in CAVA, you see some CAVA results here, where these radiuses are actually populated on the vehicle's fascia, bumper fascia geometry. And you can draw a lot of sections here, how the CAVA has calculated this gap values and etc. And CAVA also can measure dynamically the radius at this point of location, what it has found on the geometry. Yeah, this is possible with CAVA. Again, for the complete front fascia, like the complete fascia, the lenses, lamp lenses, and grills and hood and fenders, it can be all checked with the help of CAVA for the ECR 26 regulation. And not only that, but the mirror housings and etc. can be also complied suitably with the help of CAVA. As you see here, there's a spear touching the bottom geometry, and it has found some green and some red points here. So red points are not compliant, green points are compliant here. Okay, from ECR 21 point of view, which is interior safety regulation, it classifies into 4 different type of zones. Something called as level of instrument panel has to be first marked, LIP. And above that, everything above LIP is actually falls into the head impact areas, and everything below that is kind of knee impact zones. And there are some other interior fittings which has to be verified in a different way for these regulatory minimum radiuses. Yeah. This is how a physical test setup, maybe your IDT team, indoor testing team, or maybe some internal testing team will possibly check it inside that, or maybe you give this to certification bodies like ARAI or VRD, where they will check it. This is a method of checking. Like they will first put the pendulum in the rearmost position, and then they roll the geometry, the spear geometry, onto the complete circular fashion onto the IP. Then they take it forward, which is the foremost condition of the mannequin, and they mark the same activity, and then you get a complete zone here, which is actually a technical head impact zone, where these different populated people will possibly bang their heads in the case of accidents. So these has to be complied to specific regulations or radius requirements, what we saw in the previous slide. So this is a typical method. The same method CAVA does into the digital environment with the help of their algorithms. Yeah. So this is slide where it talks about the same here, which is performed the head impact zone here. We'll see, and it has found many green and red areas, especially on the bezels, HVAC bezels, and etc. And some projections are there. We'll see that in a couple of minutes about the demo. Again, how to measure and determine the projections for interior components and projection fitments. So these red points corresponds to non-compliant areas, and you can populate. You can at any point you can calculate the section, dynamic section there. You can also make it into a CAD drawing so that you can export this as a CAD drawing to drawing environment. Yeah. So as we said, in ECR talks about the knee impact. So this purple line following is actually a level of instrument panel which separates the top zone and the bottom zone. So everything below is falls into the knee impact zone, for which the regulations specifies the knee form test here, which has to be performed for the regulatory radius checks and gap checks, etc. So same can be performed in CAVA also. You see some green points which are compliant, and there are some red here which are not compliant. So these areas need correction. The style needs correction here. So once you perform CAVA activities, you can produce these results to your studio team and ask for the style corrections according to the regulation. And possibly in just one iteration, you will have a very clean surface and regulatory compliant surface here which you can take and do your or kickstart your engineering activities on that. Yeah. Again, it's again on the exterior. We have some hood, fender, and lamp geometry here, where CAVA can really help you to perform projection activities, projection measurement. So it's a hood area, it's a fender, and you can specify the split curve here, shut line here, and then CAVA can roll out the complete sections throughout the geometry here, and then you can found at what sections, what are the projections. Usually technically they are never flush, either it's under flush or over flush. So this regulation really puts limits to its over flushness and under flushness from between the hood and the fender. So CAVA, you can use CAVA and ask for demand for the style corrections from the studio team if you found any uncompliant or non-compliant areas. Similarly for IP, there are some projections you have to check, and you can have to ascertain the projection heights, which is again a regulatory by nature, as mentioned in ECR 21. So you can perform that kind of checks also in CAVA very quickly and efficiently. In CAVA, there are two methods, like one circle touch method and two circle touch method. So rolling geometry is something like instrument panel where the sphere will come in a rolling way when you roll the sphere, and then touching geometry is where we want to measure the projection here. Rather than when it makes the contact with the touching geometry, for example, any knobs or something, the sphere is lifted, what we call technical the lift value, which is actually a projection value. So CAVA can give you this height value, which is the projection value. So that's how you can classify whether this projection is within the regulatory zones or within the regulatory values or not, and then look for style corrections and etc. Also, CAVA is capable of ascertaining the same radius requirement on the seat also. There is a ECR 17 regulation which classifies the complete seat structure into three zones, 1, 2, and 3. It starts from the SGRP value here. So there are different radius requirements on different areas. So CAVA can check your complete seat structure and provide you very good feedback about non-compliant areas. Then again, if there are some non-compliant areas, you can demand from the studio team about the style corrections very quickly. Again, I think it's the last slide. We'll quickly move to afterward this the demonstration. So CAVA is available on CATIA V5 as we saw that, but it's also available equally well on 3D Experience and CATIA V6 platforms, and also for the Siemens users, Siemens Annex users, there's available platform, available solution like CAVA, which can be availed to make compliance checks into the Siemens Annex platform. I think that was it, and we will look at our happy customers all over India, all the globe. So it's a very popular application all over the world. People use it. It's predominantly used in Europe and Americas and India, and we have habit of I mean, a lot of OEMs have it, like car OEMs, truck OEMs, and also a lot of component suppliers, OEM subsystem OEMs like seating and mirrors and etc. They're users of CAVA from decades now. Yeah, I think with this we'll start with a small safety demonstration right into the CAVA, which will take, I think, at least 10 minutes. So let's start that. I will move to my session to CAVA workbench here. So I have an open session with some instrument panel, some basic geometry here, very kind of a basic IP style here with some seating structure and some fascias and etc. Yeah, and some consoles. We'll perform the checks. As I said, you have to first create the base data here. So for base data, everything I can found in the insert value here, insert toolbar. So I have to categorize am I performing this for a car or a truck? So if this is a car, then I have to choose limousine here. I can name my project, for example, project, whatever you want to say, that title you can give, and maybe some classification of the project you can give. It will be saved by that name. You have to provide the total overall width of the vehicle if you know it. If you assume it's also okay, because that doesn't affect any outputs, body widths, FOH and ROH values. After that, we go to wheels and we specify the wheel centers, like what is the wheel center of the right and left wheel and the front and rear. And then we provide some static radiuses here and the nominal radiuses. That's enough. We then give seat important parameters like SGRPs, which is a seating reference point here, and heel reference point like AHP, accelerator heel point is to be given. You need steering center also, and the pedal reference point, which is a ball of foot for the pedal pressing, and H point travel length, the total length of the travel from 250 or 260 millimeters, whatever you have, and also the back angle, seat back angle you can give, which is torso. I mean, you can specify back angle or you can specify torso angle also, it's okay. And you see it's a bench seat or individual seat. So it's an individual seat, it's a bucket seat, it's individual seats. And you can define some loading parameters also, like what is the curb mass and etc. This is not so, it's certainly required in real life, but for this we will omit this for today's discussions. After this, you will have this CAVA, you will have this CAVA base data created here. So that is added to the structure of the CATIA here. After that, we can start performing subsequent analysis. So I will first go to insert now. I have different modules here, what I explained in the before, like OVA. Then we have mannequin, a lot of mannequin capabilities are there. Extremely lot of vision capabilities are there. For example, the A-pillar covering, which is A-pillar obscuration, that's 6 degrees of limitation to the pillar structure that you can comply directly in CAVA. Then, of course, the topic of today, the safety, CAVA safety here, and wipers. And there are a lot of other tools like some creation tools and reporting tools are there. Yeah, and some generalized CATIA V5 commands are there, so that for these simple commands you need not shuffle the or change the workbench. These are given by default here. So we'll start with CAVA safety. We'll go to safety radius analysis, and we'll first execute one safety interior minimum radius checks here. So after clicking this, it will bring me a very simple user interface, just one user interface here, and which will ask me certain things to start the studies. For example, as I said, everything starts with the base data. So I will create the base data here. I will click the base data from the tree. Then I will select my regulation, according to what regulation I have to perform this check. So ECR 21 I would select. Then I want to create the head impact zone. Yes, I will click it. Then in that I will also have to check the radiuses also for compliance. I have to use the level of instrument panel LIP. Yes, and the steering offset, that 5 inch of 127 millimeter of offset. For that I will use this excluded area. And in the radius check tab, you will see some hard-coded values here, which came from the regulatory values are there, so they are not editable. But if you want to make this editable, you can always use this free tool here by which you can edit the value. If you want to be extra safe, for example, if you want to be extra safe and make it 2.25, you can certainly do that. But for today's studies, we will just stick to the regulatory requirements. And then you can perform many checks. All points should be checked, what are applicable, and throughout the complete pendulum range, it will check. Then I have to make the geometry selection. So if I click here, I have to declare my basic geometries, which will be analyzed in this module. So I click my top IP and I declare this as instrument panel, and I click this. This will get inside for considerations. Then I similarly go for rest of the things like the lower IP. Again, it's an instrument panel. Click it here, and similarly go for other methods. Like for example, I will just check here. Otherwise, this will take too much time. This again IP, part of IP, and I will then choose steering offset here, which is not an instrument panel, but it's a steering wheel. So I will click this and click OK. So I have inputted, I have declared bare minimum requirements for analysis. You see the apply button is active now, so I can literally perform the analysis now. But before that, I have to make a certain one thing. What are the direction of the surfaces? From which which direction the sphere is going to come. So I have to analyze this. I have to click this icon, and it will turn yellow, but it should turn green. So I will click it here. So what do I mean by blue is that uh, the the sphere will come from the observer's direction. So we are observing, so the sphere will come from this direction, and it will roll over the geometry. So if I click here, then I'm good to go with the analysis. You have to just bear with me. It will take 1 or 2 minutes to perform this analysis. This is certainly very far less time uh, that is used by manual methods. So it's again a CATIA-based application. It will consume far less time than the manual method. So let it complete, then we'll see the results directly mapped to our geometry. Some color-coded points will be appearing, which will give you a very graphical inputs and graphical knowledge about your non-compliant and compliant areas directly on screen. I think we are at the end of the analysis. I think it doesn't need at least a minute also. Of course, it depends upon the complexity of the IP, but it usually don't take more than 10 to 15 minutes for even for a complex IP. So we are ready to view the results. You see a lot of kind of green point. Those are compliant points. What I will do, I will just stick to the applicable points. So I will just stick to results, limits, I will say, not limits, checks, yeah, seat. You'll see a lot of things. All the green points are there, which are compliant. You can go closer. You see a lot of invalid points appear in the gray here, which are actually the valid points, but those are not touchworthy points. I mean, so these points are omitted in the analysis. I have performed the driver analysis. Similarly, I can perform the passenger analysis also equally well. Similarly, in the similar fashion, they will appear in two different line items here, one for the driver and one for the passenger. So if I have to analyze the results, so if I have to go to the results tab here, so it has checked totally 46,774 points it has checked, and it has found 748 non-compliant points where the radiuses are below the regulatory values. And the total unreachable points are 31,000, which can be ignored for a moment because they are not reachable. So there is no radius requirements there. Then we'll see results here directly, or the violated points. These are the all list of violated points which are CAVA has found for you, and it has given that as a one user interface which you can completely select this, and you can export their generating faces in terms of geometrical output. You can export this point into CSV file also, which is kind of a 3D coordinate data file, which you can make a script and import back into CATIA. It's possible. Then I will just select one thing here, and I will select this, double click this, by which I will come to the maximum radius here. So I will click here, and I will go to section viewer. No, for that, I have to first drop the window. I have to go put a frame on here. I can export this very well right into the environment. So this is a non-compliant point it has found. This is a greener. But the more interesting is to visualize the interactive results. So I uh, can put the sphere on any point here. For example, if I click the start here, and if I click the point here, go to snap mode so that it will snap to the point automatically, and it will drop the sphere here. directly. So you see the kind of a spear here directly, which is giving a good idea at from what angle the spear is coming, and the rolling geometry, and it's creating the contact here. You can also measure the radius. It's 2.717. You can also you can stop here now and analyze the section direct viewer. I think the section is not available here. We'll go to another point maybe. Yeah, I think some of the point is not appearing here, but the points are very much, you can see the sections here directly into the geometries. Yeah, and from visualization you can do a lot of things. You can hide many points here, like if you just want to see the violated points, it will become red. So I will just hide the invalid or compliant points into the hide and custom as hide. I will just be able to see the non-compliant points. So it will. So definitely the bezels are the culprits most of the times. So these are non-compliant areas here. You can go to the interactive check again and perform this on the go or dynamic analysis here. If you click the section here, the spear will be dropped. Yeah, if you go closer, you can snap it. You can perform the regulatory check here. It will give you a good idea. Then I stop here. Then I stop here and I go to section. I think the section is not appearing, but usually the sections appear here. Something is missing wrong here. So you can perform the radius checks likewise. So I think this is what, I mean, we did not even consume 1 minute for this analysis. Otherwise, to analyze this in manual methods, it's quite a cumbersome job, I will say. And you can perform to any number of limits. There is no limit. You can re-engineer your surfaces accordingly. I think that was it from my side. I think thanks for listening so patiently about this webinar. Thank you very much. Over to you, Aniket. Thank you very much.
Okay, I think that's it. So we are at the end of our webinar. If you have any more questions, you can see the contact details on the screen. You can directly mail us or contact us, and we would be happy to help you. So now I would like to thanks Mr. Sushil and Mr. Chandrakant for delivering a very insightful webinar today. I am very confident it was very helpful for our audience today. I also would like to thank our audience for taking their time out and joining this session. If you have any further queries related to the subject matter or any other requirement, you can always connect with us. Please do keep an eye on our upcoming webinars. You can follow us on our social media platform for the same. Thank you.
Thank
Thank you
you.
very
Thank you all
much.
guests. Thanks a lot for your time.
Bye.